Oh, hello. So, my name is Yasir Usman, and today I'm going to talk about world models. So, a brief introduction about me. I am working as an AI engineer at a company in Pakistan, and I have a master's degree in AI and a few publications. So, today I will talk about world models. So, we just, yeah. So, like we have LLMs. So, LLMs are like in a way to predict the next tokens, but LLM do not behave or do not like mimic the simulation or reality of how things work in real world. So for that we have world models. So what are world models? Basically the from to token prediction to the physical understanding of how things work, and we will discuss what is JEPA and VJEPA and how they can improve AI. So people think AI in general as just LLMs and that is the end of AI. But here, like if you go into the maths or like if you go in a Hugging Face and see how many models are being developed today, it's way vast and way more than that. So yeah, so for first we will discuss the limits of today's AI. So what is and the difference between the token prediction and world understanding. So large language models have achieved like for example, if you work with Claude or ChatGPT or something like that, that is have improved the working is greatly. Uh, but the problem with that is it's only limited to the dataset and cannot hit on its own. So like nothing new can be created from like an LLM. If totally like it would have patterns of previous data because that is what it's trained on. With humans, I think we can create and understand things better, but not only that, we can be the imagination part of the humans can't be make yet. So LLM excel at predicting the next token, but the pattern matching does not equate formal representation of physical worlds. So like like you could say like they cannot understand causation. So what like causality is if B A happens, then B happened, and so both are connected. So we could say that that is a causal structure. And then missing intuitive physics. So we have an understanding of physics and causality by observing the environment. But however, the AI system they do not know about permanence, gravity, or spatial relationship without explicit training. So like LLM wouldn't know how would gravity work if we ask it to draw a ball and may have it falling around. It would make a prediction on that as well, which is I think not the right way to go. The real world listening without the world models. AI struggles to plan, reason, and interact effectively in dynamic real world environments. So, like if we have AI, it is limited to now the best use case of AI is probably writing code. With self-driving cars, not all of it is AI. We have a lot of sensors and different things like that which make the car or self-driving car works. So not all of that is AI. So we cannot have like do not have at the moment enough application of AI in other domains except coding. So what are world models? So world model is a internal representation of environment dynamics that enables an agent to predict, reason, and plan rather than reacting to sensory input. So with LLM or like current AI, we would react to the input and we would be based on our data. An agent with a world model can simulate the consequence. It can simulate the output without it having the output before. So something like a chess player which can predict what would happen in later states. Some of it you could relate with reinforcement learning and like Mo Zero or something. Some method like that can uh, be related to world model. This concept so yeah, the human so according to psychology, Kenneth Craig. The human mind constructs small-scale model of reality to anticipate the outcomes of action. This cognitive architecture allows to avoid dangerous trial and error in the world. So, like according to psychology, how we work in real life is we are constantly predicting or imagining things. So even in our mind, like if we're driving a bike, we're constantly thinking about what could come up next, and in some way or form, our mind is prepared for that. So the core properties of a world model would be internal representation of environment dynamics. It would support prediction of future state. It would enable reasoning about cause and effect, and facilitates planning without real-world execution and grounded in physical and temporal structure. So for AI, building world models is to imagine, like if AI can predict the future, like imagine it in a way, then act accordingly rather than taking the past and using it as a to go ahead. So a little bit about JEPA. The JEPA is Joint Embedding Predictive Architecture. So like what would JEPA do is help us predict the representation of the world or help us do the prediction or representation of the world in future in a way. So prediction representatives is far more efficient and semantically meaningful than pixel level generation by encoding inputs into comparing later vectors before predicting. So we are taking our input and we using an encoder and encoding into vectors. So JEPA cites as the complexity of modeling every visual detail. So like with JEPA we have like if we have images, like let's not think of them images and then we have them as vectors. So that reduces this complexity in some sort. So generative models suffer from nuisance variability, wasting capacity on irrelevant visual details, whereas contrastive methods introducing negative sampling bias. JEPA elegantly avoids both pitfalls but predicting only what matters in latent space. So it is kind of a self-supervised since, or you could say like in we do in unsupervised learning, we have a data set which is not labeled, so we can use that to predict the next output or make clusters. But with this way, we can sort of predict the future and train the model to act accordingly. So we have a encode step to map the input to later representation. Then we predict, uh, and then we learn the model one dynamics without labels. For example, we learn about gravity. So this could be something like that. This architecture enabled model understanding the structure of the world and how things work. So it could better, simulate a human better. Evolution of JEPA from images and to video. So with JEPA we have like three major iterations. We have iJEPA which is for image. We have VJEPA for video based, and now we have VJEPA 2 to which is state of the art at prediction and understanding. So like main goal is to like bring AI to other parts of life or other than code or something like robotics or which should enable us maybe the future to have completely autonomous systems. So VJPA 2 would is trained on the droid dataset of robot interaction. So it demonstrates the capability that previously thought to require extensive specific training. So physical manipulation, it can perform reaching tasks, we can place tasks in unfamiliar environment without prior exposure, just how human would be able to it would have contextual anticipation. And then zero shot planning. So internally our goal would be, say, if we throw a human in the lab, it can figure things out. Same should be the case with a JAPA model, which would have no training on that specific type. So the JEPA 2 architecture is a two-phase training. We have self-supervised pre-training. The encoder and predictor are trained on the abundant natural video data. So, and we have no labels. So, if you in machine learning, we have features and labels. So we have like no labels here. During the phase, the model bootstrap its understanding of world dynamics and then how the world works. And then a small amount of interaction data is given to train the model. So since the model already would understand physics and dynamics, it would require fewer demonstration and would be able to do it. So this would help us to do the real sort generalization. So we JEPA probabilistic world models for robust planning. So probabilistic generalization of JEPA learns a predictive distribution or future line estate, not just a single point prediction, which would help us to do things out of scope in a way. So if an LM is trained on coding, it would perform poor on like writing task or like writing an essay. With JEPA, we would be trained on one thing and would auto learn in a way. So it would incorporate Bayesian filtering, would enable principal uncertainty estimation and support likelihood replanning. Why probabilistic matters? Because real world environment are inherently noisy and partially observable. So like we have in an environment different inputs and we can't really predict what would happen in the next step since the real world is not linear. So with JEPA, if you I have worked with this MPC, so MPC would be a method to induct a model predictive control system where we would take the output, feed it back, and in a way try to predict the future without like if in a normal feedback loop we take the feedback and input it into the future to input in the present to make the system a feedback loop improve it on itself. If we can predict the output and use that to improve the uh, current output of the system to increase the efficiency or whatever measure we are trying to. So we would encode the current state, we would sample, and then we would predict, and we would choose action to minimize the goal. And yeah, so yeah, I think the slide got lost. So what I was saying is we would use some sort of MPC kind of structure in order to uh, use the model. So yeah, the energy function, the planning is framed as energy minimization representation space. So we have a predict and uh, with A1 of H and Z current with the minus with the Z goal where Z goal is the encoded goal image. So optimize the search for action sequences that minimizes the distance between predicted and goal at a state of value guided action planning. Advanced intent first shapes the implementation state to approximate goal condition value function, which will provide better guiding toward the action that are not geometrically close to the goal but causally effective. So again, the causality thing is coming up like if one state could affect the next one. So the future of machine learning. So yeah, the last slide. Uh, so with more JEPA, we could have like advanced machine learning that could perform other than other areas of life without with incorporating us like sensors or something like with again going back to the example of electric cars where we have sensors or something like that in combination with other AI tool, but it's not completely AI that is driving the car, otherwise it would crash all the time. And so we would have robotic assisted intelligent wearable AI and open research. So Meta is raising the JEPA 2 and new benchmarks. So yeah, this is the path to AGI runs through world model. So eventually world model would take over the LM, then this would be the next major advancement in AI. The slides are made through Gamma, and if anyone needs it, I would be happy to share them. So yeah, that is it.